architect. Okay. And I have done so many projects on migration, and currently I'm working on the Snowflake with DBT, building a new warehouse. So such kind of things I work, all the automation and all that, right? I have done that. So here I am coming to teach you about the Snowflake, right? So anybody knows what is a Snowflake? Because Snowflake is already boom in the market, right? So you have any idea of what is Snowflake actually? Hello? Hello?
Vicky, we'll take the questions at last. We'll
No,
go
no,
to.
I just want to understand, right?
Oh, yeah.
What exactly they know that Snowflake, right? So any idea, anybody?
Snowflake is a cloud data warehouse.
Correct.
It is a SaaS. It is come under SaaS, software as a service.
Yes, that's correct. So basically, what happened, right, when the data started, right, in the 90s, right? So that time the storing the data is very costly, right? You remember that, right? When at the time we are storing the data, we have seen that, right? How the floppy work, then floppy to then CD come, then hard disk, and now terabytes are coming, right? So that time, what happened in the 90s, right? The storage is very costly, right? So to store that data, right? It required, we need to think on that, right? Now what happened, right? The data is growing very fast, right? Social media, YouTube, Facebook, so many things are coming, right? So in that case, what happened? The storage, we required more storage, right? So why we required the storage, right? To do the analysis, right? So in this what we are trying to show that, right? See, in the 2020 we are getting the 40 gigabyte of the data. That is a old slide. Okay. So previously we started in the 90s, right? If you see that Oracle, DB2, MySQL will be there, right? Slowly in 2010, 2000 to 2010, right? The big data, this Netisa and Vertisa and Teradata will come, right? In 2006, right? BigQuery and these things have come. Okay. So in 2015, that Snowflake has started, right? So why the Snowflake, right? So how the Snowflake come into picture, right? So what happened, right? And there are the two persons, one is from the Teradata and one is from the AWS, right? They together join and they come with a new concept of Snowflake. What they have done, right? They use the existing public cloud, right? And they build a tool on that public cloud as a software as a service. So in case of traditional warehouse system, what happened, right? To build a warehouse, right? We need to plan accordingly, right? What will be my data after the 5 year, 2 year, right? Accordingly, we need to buy our hardware and software and all that, right? So to overcome that problem, right? So these guys come with a Snowflake, right? Software as a service. So what is cloud actually? Cloud is nothing, right? There is an on-prem and the cloud is there, right? In on-prem, what happened, right? We are having own everything. Server will be there. The maintenance is done by ourselves, right? But in cloud is just like a you can say that cab, right? Instead of buying a car, you just from your mobile, just to book the cab, you will get it, right? So whatever you are using for that, right? That only for you need to pay for that, right? So that same concept they have come with, right? So so I will show you that it is founded in 2012, the Snowflake, right? So they built this Snowflake. It come into the public, right, in 2014, and they built the first cloud they have used as a Amazon, right? And after some year, right, 2-3 years, they use the Azure. Now it is in 2019. It is the Snowflake is built on the GCP, right? So in 2019, right, this is an old slide. This is a rank, number one rank is there for this, right? So this is all the history of the Snowflake is there, right? So what is Snowflake, right? So Snowflake basically, why the Snowflake? Why can't we do our on-prem only, right? So to take the advantage, right? So here, what we are doing, right? Here is software as a service, right? Everything is maintained by the cloud provider where you are going to build out, where you are going to build your Snowflake account, right? Suppose your company is using a Azure, right? So in that, just you need to create an account in the Azure, and the background, whatever the cloud is there, it is maintained by them, right? But for that, the Snowflake charge for that, right? So when we come to the traditional warehouse, right, in that hardware is required, right? Maintenance is required, right? So suppose you have started you have purchased a server, right? The server maximum size of the RAM is 32 GB, for example, right? Now our data size or our system got slow. Again, we need to increase the size, increase the space. To do that, right, it required a downtime, right? So your downtime means, right, your application is down. Suppose, for example, let's see, let's say you have started a online business, e-commerce, right? And for the e-commerce, if your system is down for a 1 hour, so that system is used by a multiple customers throughout the world, right, over the globe, right? So you will lose a lot of things, loss will be there, right? To So that's why the people are moving to cloud, right? Because everything, maintenance, hardware, no software. Some like I'm using Oracle, right? So every 6 months, 1 year, the Oracle is sending some patches, right? We have come up with a new feature to upgrade the software, right? We need to reboot the system. In your mobile also, right? Some upgrades are coming, right? So once we install that upgrade, our mobile is reset. We need to reboot the system, right? So here to overcome that, right? this the Snowflake come into picture, right? So Snowflake is basically there is no hardware required for the Snowflake, first thing, and there is no software required, second thing. So like previously to install the Informatica, there is certain limitation is there, right? Your system should be have a 8 GB RAM, okay, and it should have this much space in the hard disk and all that, right? Here, no software is required. Just you need to create an account in the Snowflake, whatever the cloud provider you are using. Okay. Here, one more thing is there, right? Here, it is mainly used because here compute and storage are decoupled. When we say compute and storage means I can increase my capacity, right? For processing speed, I can increase my RAM size and all that, right? Storage, suppose I want only 1 TB of data, right? So I want only 1 TB of storage. Suppose after 2 months, I am expecting that the festival is coming, right? So more data will be stored into my system, right? So I can upgrade to 1 TB to 2 TB or 3 TB like that without downtime, right? So here both are the things are decoupled. Decouple means either you can increase compute or you can increase storage or you can increase both. Okay. And it is a cloud agnostic, right? So that means it can be work in any of the cloud of your choice, right? Like for example, in my previous company, where I'm working, right, there they are using the AWS because they are using AWS. My current company, we are using Azure. Okay. So this basically work on pay as you go model, right? So how much hour you are using, that much you have to pay. What is the your query is taking time, that much you have to pay. So pay as you go model is there, right? So it is not like that way. It's a fixed like monthly you need to pay like that way. No, it's it's a depend on the plan, right? How we are using our mobile, right? Postpaid plan is there, prepaid is there, right? In prepaid we are just recharging, right? I want to recharge for 300 rupees for 28 days. Okay, recharge it, do it, right? One is postpaid plan, right? There the bill will come every month, right? Like that way. So the plans are there. So so it is then Snowflake features are there, right? Built for a cloud, right? So in the cloud, right? Uh, there is no limitation of the storage, right? We can increase at any time and do that, right? So build on the cloud compared to the traditional our warehouse system. It is a software as a service. We all are using the software as a service, like our Gmail account, right? Google Drive. The Google Drive is a free for us for 15 GB, but it is software as a service. You save your documents and anything you want, and you can access from anywhere. Just you need an internet for that, right? Here, the third point is that pay only for the use and compute. Suppose you are not running any computation, you are not doing any query, just you are putting the data. So you need to pay storage. If you are doing some processing and all that, so you need to pay for the compute. Okay. And both the bills are different, right? Sometimes the bill will be both different will be there because I just use for the database only. Okay. Here scalable. What do you mean by scalable? Suppose I today my business is running. I just started a startup is there, right? So I just required it one server only. Okay. After that, after say for example, the festival season come, right? So I have started my sales and all that. So that time I am suspecting that so many traffic will come to my portal and all that. So I need a more server. So in case of traditional system, right, we need to forecast before doing this, right? But here what happened, right? Whenever you want that server, you can be scalable, right? You want two server, three server, just click on that and within a second it will be up and running for you. Okay. So when we say on-prem, these are the three terminologies are coming in the cloud when we are working in the cloud. Infrastructure as a service, okay, platform as a service, and SaaS as a service, right? And on-prem is there. So here I am trying to explain you with one example, okay? Like on-prem means you have own car, right? So that car is maintained by yourself, right? You need to do a maintenance every month or after 2000 kilometer, you need to change the oil, petrol, and everything, right? And insurance and all that you need to take care. So that is the on-prem. So that means when we connect to the IT world, right? So our server, okay, for the server, what are the things required? One person required, expert, right? Server expert, networking expert is required, okay. And for this on-prem, we required a one building, okay. AC should be maintained, cooling should be maintained. So everything should be, electricity should be there. Everything should be maintained by us, right? Infrastructure as a service means like a self-driving car. So like a Zoom car, right? They will provide you with a full tank car. They will say that this is the car, use it and give to us. So invest just whatever you are using for that. So these things taken care by the provider, right? Like a platform as a service, right? So in this, right, what happened, right? So we have a multiple choice. I want to go to airport, right? So I can go by Ola, I can go by Auto, or I can go by Uber, right? So it is a platform as a service. In this case, what happened? Insurance, maintenance, nothing to worry. Just you need to call book the cab. It will be at your door. Just take the complete your journey and pay it. So that much, no need to do investment. So on-prem, suppose you want to buy a car, minimum say 5 to 10 lakh, right? Here you are not doing that. Here, whatever the choice of car you want, you can book in the infrastructure service. When we say public transport, right, like we have a buses, right, or we have a train, right? So these are the public transport, right? So where it is a software as a service, just pay one ticket and you can travel, which is lesser than the compared to all this, right? So hope this is clear, right? So, so when somebody told that, right, what is Snowflake, right? So Snowflake is basically a cloud data warehouse, okay, built on the cloud, okay. Why Snowflake is so famous and why people are, every company, clients are moving to that? We know that the legacy system, right? In the legacy system, mainly we are writing the SQLs, right? And some Java code and all that, right? That is the legacy, right? So they what they have done that, right, using the cloud, they have given the same comfort. The person who knows SQL, they are very much comfortable to write the queries, the same query in the Snowflake. Okay, the way of writing everything is same only. Okay, here that there is a zero management, right? So first is it is giving the full compatibility with the SQL. If the person knows how to write the SQL, the same SQL he has to write in the Snowflake. Okay, this is only the way to change. Previously you're writing in SQL or SQL Server, the same SQL, slightly change the syntax. Okay, 90% syntax are same only. Slightly there is some new features are there, but they can work, right? Now there is a thing, right? There is a zero management, right? I told that, right? So there is no worry about the management, right? If anything some patches are come or some upgrade are come, it is done backend. It is done backend by the Snowflake team itself, right? Because we are paying, right? Like you are using the cab here, right? And anything happen to the cab, right? Then Uber is doing the everything, right? We need not to worry about whether the insurance is expired, diesel is there or not. How is that? Everything should be maintained by them because we are paying for that. We need a facility. Okay. Similarly here also, right? All the type of data it's supported, right? So in the relational database, we are just using the structured data. In Snowflake, it supports the semi-structured and unstructured data also, right? And it is all for all the users. Okay. And the other feature is pay what you use, right? So suppose you are running the Snowflake for 1 hour, so you need to pay for 1 hour because it's start for whenever we run the warehouse, it will start minimum we need to pay for 1 minute. 60 seconds we need to pay for that.
Sorry for
That is a
disturbance.
sorry.
How to handle the unstructured data in Snowflake, sir?
Unstructured data, right? So how we are doing, right? So we have a here variant column is there, right? So that variant column we are loading the data, right? That way we are loading that. I will show you that, right? And
Okay.
here we have a live data sharing. Suppose you are using a Snowflake and the data is there in the Snowflake and your client, right? And you want to share the data with the client. So in the traditional system, what happened, right? We need to generate the file and give the data to them over the email and all that, right? But here we have a feature of data sharing, right? So what we will create a one reader account for the uh, customer to whom we want to share, or if the customer is also a Snowflake user, then we can share the data. So there we are sharing the data within a second. No need to send any file or email and all that, right? So your data is in the Snowflake. The customer will come and log into our system and read the data because we have provided the privilege to that.
In Azure and Redshift, there is no option of data sharing.
No, there is no sharing.
Okay. Can
Okay.
you explain about what syllabus you are taking?
Yeah, I will come. Let me complete, right? I will. Okay. So what's your good name?
Azure.
Okay, Azhar. So this is a single place, right, where we are storing the data. Okay, we can scale and then we can do the concurrency, right? Suppose my system is used by multiple user, right? So that time what happened, the load will come, right? So we can divide the server in such a way that, right, it will handle the concurrency. It is not like that one query is taking long time and other queries come in the queue waiting for the resource to release and then the second query will run. No, we can run it parallel using that multi-cluster cell disk architecture. Okay. So these are the features of the Snowflake, right? I told you, right? So there is a feature called zero copy cloning. Suppose I have a data, right, in my production environment, and there is some issue come in the production environment after the deployment. So same issue we can reproduce in our dev environment by getting the data from production. Okay. So previously what happened, right, when we are doing the backup. So that time what happened in the traditional way, we need to raise the request for the DBA. Then DBA will create the backup for us. Then they will share. So it will take 1 or 2 days of time, right? And some approvals are required, right? So if you have a privilege, right, you can clone it So in the cloning, it is saying that zero copy cloning. So that means we are just
Vicky, sorry, Vicky, for interrupting. Are you changing the slides?
yes.
But it is on the Snowflake slide only.
Oh, oh, it is not changing.
Now it is changing.
So this slide you didn't see.
Now I am able to see this Snowflake features. Earlier, the Snowflake slide was there. Sorry. Please continue.
So this one I shared that, right? Hello.
No,
Hello?
no one.
Can you share now?
The slide sharing was not done. Anyway, we listen you.
Can you, are you able to see my slide now?
We
Now
can see.
Yeah. So this is the thing I am showing. Let me repeat it again, right? On-prem, we have a buying a car, right? In the infrastructure, self-drive car. Okay. And in the past, we have a taxi, right? So, and SaaS, we are using the public transport. Okay. So that I explained you, right? So these are the thing so these are the feature, right? So here we have a multi-cluster architecture. What is multi-cluster shared disk architecture? I will explain you. There is a feature of time travel. So what is the time travel? That means we can go and check the history. Suppose on 1st August, what is the situation of my database at that time? So suppose on 1st August, there is a 1 million records are there. Okay. And today we have a 2 million records are there. Now what happened, right? Out of that, some records got deleted today, right? But I want to see that old record, right? In the traditional system, what happened, right? We can't go back and bring the data, right? But here we have a time travel feature is there, but some retention period should be there. It depends on the edition you are using. Okay. So what is the history of my time travel? Just going back to that time, right? So suppose you have a table today at 9 a.m. in the morning, some 10 records are there, and by mistake, some junior has run a update statement, update employee where salary equal to something. He has done that. So all records are updated. Now it's very difficult to get which one is what, right? So what we'll do for that time, we can go back. At what time he has run the query, we can go to that particular time and go back and bring that. Okay. And there is a feature of fail safe. So once our time travel uh, period is over, right? The maximum is 90 days for enterprise edition. Suppose after 90 days, you are realize that, right? I need a data, right? So we have a 7 days of fail safe is there. So in that case, what happened? Only the Snowflake, we need to connect with the Snowflake customer care to get the data. For that, they will charge for that, right? Here in the traditional system, right, when we have a like a sales data, sales table is there, and I am running a business from 2010 till 2024, right? 14 years of data is there, right? So you can think about that retail business, how huge volume record is there, right? So in the traditional system, what happened, right? We are creating a partitioning, right? So we are creating a partition by the year or month, right? Why we are doing that? Suppose I want to go 2010 January data, right? I am interested to that read only, right? If we don't have a partition, it will read all the data, right? So, but here what happened, right? Automatic partitioning happening, right? No need to do any user interface. Automatically, the Snowflake is maintaining. How to do that? I will tell you. Okay. And here we are doing the parallel computing, right? And data sharing, I told you, right? Here, zero maintenance, we told. Here we have a result cache, right? So result cache is means, right? We already heard in the Oracle, if somebody work on the Oracle database and any other database. So what will happen if you're running the query first time? It will take some time. Suppose you are running a query, select a star from Android. It is taking 5 minutes to bring the data. If the same query you are running, it will take 2 seconds to bring the data. Why it is so? Because whatever the result is there, right? It is saved in the cache. The condition is that the query should be same, exactly what you are writing. Suppose you are writing select star from employee, all are in uppercase. The same query has to be fired again, so the query will be there. So you have heard about, or you face such kind of question in the interview, what is hard parsing and the soft parsing, right? So hard parsing means it will first, whenever the first time we are passing run the query, right? So it will see the query, right? Select star from employee. First, it will check the user which is firing the query is having a privilege to this table or not. If it is having the privilege, then it will go to the optimizer. It will generate a explain plan, right? So from the explain plan, it will go to the storage location, bring the data to the memory. It will take time. That's why it is taking some time. But in case of when we file the same query, right? So what will happen? It will not go for that because this query already run, right? The result which is get, it is stored into the result cache. So this result cache, right? The data, suppose I run the query today in the morning, right? So this result will be there till 24 hours. So within 24 hours, anytime I am running the query, the result will be very fast. Only the condition is that the underlying data should not be updated on any changes. If suppose 100 records come in the morning, 9 o'clock, right? And evening 8 o'clock, I am seeing 150 record. So that result cache will not work because it need to be refreshed again. It will take time. Okay. So these are the advantages of the Snowflake, right? Here I told you, right? Storage and the compute cost are different, right? If you are using only for storage, you need to pay for that. If you're using for both, you need to pay for both, right? Okay, pay what you go, right? So suppose today, this month, I am using Snowflake, no computation, right? I am not running any query or dashboard, right? I'm just whatever the data is there. So because storage is very cheap, right? So storage cost will be there. Okay, next month I am running multiple huge, very big queries and all that, right? So that time I need to pay for the storage and compute. It is a software as a service, right? So no maintenance, no installation, no upgrade. Everything is taken care by the Snowflake. And the timetable I told you, right? So timetable, suppose I want to go and check the data. What is that? Suppose if you write the query, select a star from employee and you are seeing the salary is uh, uh, say 10,000, right? But in the 1st August, what is the salary, right? What is the account balance you can see. So just go and back, run the time travel query. It will show you the back picture of the query at that time, right? What time you want to. 5 minute back, you can go and check whatever time. And zero copy cloning line. Suppose I have a prod data, I want to clone that. So it is not doing any data storage. Suppose I have a data in the production, right? 1 GB or 1 TB of data is there. I want to bring into my dev environment. So cloning means it's a clone. It is not bringing any data. It give you that, what is that location to, it will point that location. You can read the data. Okay. For that, no storage. So 1 GB data you are just cloning. It doesn't mean that in your storage you need to pay for 2 GB, because that's why it is especially saying that zero clone, right? Zero copy cloning means it is just doing the cloning, but it will not need not to pay. Okay. Data sharing means we want to share the data, right, to other customer, right, or my client, right? So we can share the data using the data sharing. So we will share him the user ID password. We'll create a one reader account for him. What are the privileges and all that? Or if he is a Snowflake account, a Snowflake user, we can give the data sharing to him. He can access, he can write the query, just only read only. He can't do any DML operation. There is a feature of undrop. Suppose you drop the table, right, and you want to bring the table back, right? You can go and bring the undrop. Scalable, right? So you can increase the compute power, right? So I will show you that how to increase that compute power. So in the, this is a very high level diagram, right? What we are doing here, right? So we have a source system in the on-prem, right? And then we are bringing the data to S3 bucket. Then we are bringing the data directly. We are loading through the ETL tool, right? Here we are using the virtual warehouse. Here different labels of the data is there. Then we are using different virtual warehouse for. So suppose we have a staging, routing, and all that. So for each, I am using different compute. Okay, so that is the flexibility it's giving. It's not that whatever the compute I am using for loading, at the same time the user want to fire a very big query, so it should not slow down, right? So that's why this it is in a multi-cluster warehouse. So this is the difference between. So these are the competitor for the Snowflake. So before Snowflake, right? So we already have a warehouse on the cloud, right? AWS Redshift and BigQuery in the Google, right? So they are the competitor, right? So there are slight difference in that, right? So so the thing is that the first difference is that the Snowflake gives the flexibility, right? You can create an account of Snowflake in any of the cloud as you want, right? But Redshift is a product of AWS, so you should be the customer of AWS. You can't build the Redshift on the Azure or BigQuery, and like BigQuery is from the GCP. Okay, so here what architecture is there, right? It is a multi-cluster SanDisk architecture. Here a massive MPP they are following, right? And they are following the serverless, right? So these are the things are there, right? Here we have a somebody asked that data sharing, right? So here we can share the data, right, in the secure way. Here it is supported only to a cross account sharing is there, right? We can't share with the other account and all that, right? Okay, so here if you see the cost model, right? So here pay as you go model is there, right? But here both what is that, compute and the storage are coupled. It's not decoupled, right? Whether you use compute or storage, you need to pay for that. Okay, here the optimized fast query performance there, right? Here also fast query performance there. The time travel feature is there here in the Snowflake, but here is the only limited history, no time travel feature is there. Okay, and here it is supporting to any of the BI tool. Either you can use Power BI or Looker or Tableau. Here they are supporting, right, compatible with the AWS, which are the tools are compatible, right? So they are doing that. Okay, so I'm talking about the multi-cluster architecture, right? So multi-cluster architecture is basically is nothing, right? I'll show you that. This is a multi-cluster architecture. So first we need to understand what is multi-cluster, right? So if you see this, right, so it is a combination of two architecture. Okay, one is shared disk and shared nothing architecture. So they combine both the architecture together and come up with a multi-cluster architecture. So first we need to understand what is shared disk and shared nothing architecture. So shared disk architecture means, if you see the diagram, right? So we have these different nodes are there, cluster nodes are there. So they have their own CPU memory, but they are using the common disk, right? Storage is common. They are interlinked by the um, bus pipelines, right? In the shared nothing architecture, what happened, right? They have their own disk. Okay, these nodes are there, CPU memory is there. Okay, and here they have their own disk, but they are interconnected, right? So what definition is saying that, right? In the shared disk architecture, right? The cluster nodes are shared the storage device, right? And each node has its own CPU and memory. But the problem is that, right, if anything happened to the storage, right, I want to increase the storage, right? So we need to win that the system should be a downtime is required, right? Any machine can be read, any machine can be read and write any portion of the data because it is central storage. Okay. So only the performance, the scalability, and these are the limitation, right? How much you can increase it, right? But here you're able to see, right? Shared nothing architecture PPT, right? Just want to confirm. Hello. Hello.
Yes, sir.
Yep. So just want to confirm. So shared nothing architecture in this, what happened, right? They have their own CPU memory along with the disk, right? So in this architecture, what happened, right? The 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 data is divided into multiple chunks, right? How we are using that in the big data, right? The same thing they are using that, right? So here the the model need to be the data loss if the copy of the partition data is not maintained as a backup in another node, right? Suppose this node is down, right? But the copy of that whatever the data it will be present in this. So what they have done here, right? So they combine together and they come up with the shared nothing architecture, right? So this is the Snowflake architecture. In the Snowflake architecture, we have a three different layers. Okay. So one is cloud service layer, query processing layer, and data storage, right? So, so basically we need to work here, this cloud service layer. Okay. This is internally maintained by the Snowflake. Okay. And these are the storage used by the cloud which we are using. So for example, I have created my Snowflake account in AWS. So my storage will be by default is S3. So that storage, suppose you are a AWS user, okay? So you have access to AWS. You can go to the S3 bucket and all that, right? On the top of that, you have created a Snowflake account on the AWS. So ultimately what happened, the storage in the cloud for AWS is S3. So you can't go and check whatever we are storing from the Snowflake, it will go to S3 bucket, right? That it will be hidden. That will not be allowed to AWS also and you also, right? That will be taken care by the Snowflake. Snowflake where team has access to that, right? Okay. So whenever we are storing the data from Snowflake, right? To the Snowflake, when we are storing the data in Snowflake, it is in the backend is basically storing into the cloud storage. Okay, like Azure, it's a blob storage, right? So to access this data, right, we need a SQL. Using the SQL, we can get the data. So I told you, right? So this is three-layer architecture, right? So cloud service layer, okay, query processing, and the storage layer. So when we come to this, right? So I told you that Snowflake is a hybrid of traditional shared disk and shared nothing architecture. So if you go to the documentation, you will read that, right? Multi-cluster shared disk architecture will be there. So it is nothing but the hybrid of this, right? We have hybrid disk, shared disk, and shared nothing architecture, and they come up with a multi-cluster architecture, right? So it is three-layer cloud service layer, processing layer, and data storage. Okay, the separation of compute from the storage. If you see here, these layers are separate here. All three layers are separate. If you see, this is a storage, and this is my query processing. This is nothing but compute layer. Okay, so there we have a all virtual warehouses are there, right? Okay, don't consider what you know the warehouse. This warehouse is different, right? This is a warehouse of compute. When we say compute, that will be CPU, memory, RAM, like that way. Okay, so that is the warehouse here. They are using that term. Okay, if you come here, right? So here we have a CPU, RAM, memory. This will be there. Here we have a storage. Okay, so I will tell you these things, right? So in the storage, right? So in the storage, I shown you this, right? So this is for the S3 bucket, right? This is for Azure and this is for the GCP, right? So, so whenever we are storing the data into the Snowflake, right? So what Snowflake is doing in the background, right? That code is written by the Snowflake team. They organize the data in optimize and the compress columnar format, right? So first we need to understand what is columnar format and the row label format, right? So what I show you that, right? What is that? Hmm. So before going to columnar, right, I need to explain you what is role. There are two types of database in our industry. Okay, so both are relational, like Oracle, right? So Oracle is a row-based database, right? So what basically is the row stored database and the columnar stored database? I will show you at the high level, right? So suppose we have a table, order table, right? So in that order table, we have a order ID, product, amount, date. So we are storing the data into that, right? Insert into table, order ID, t-shirt, and all that, right? So in case of stored database, right? Stored database, how they are storing? They are storing the row stored database. They are storing the row for one order. What is the row is there? One row. Second order, second row is there. But in case of columnar database, what is happening? It will store all column one. Okay, all the order ID, this column value, then product value. Like that way they are storing. Here I have shown that, right? Like for example, here we have example country, product, and sale. Okay, so in case of row store database, it will store each row, one row, two row, three row, right? But in the Snowflake, the data is stored in the columnar, right? So that's why if you see that, right, whenever we writing select star from employee, right, in the Snowflake, it is taking time because it will read each. It will go this column, it will go this column, this column. If you write select country from the table, right? So just it has to read only this part of it, right? If you need a product, this will be there. So that's why we are, as a standard, we are giving that, right? We should specify the product name. Okay. Hope this may be clear. Okay. So it is what it will do, right? It will optimize, compress the data and load in the columnar format, right? And the data is stored in the cloud. The Snowflake, so the data objects are not accessible directly, right? To access this data, right, we need a SQL query. Okay. So in this query processing, what will happen? What we are doing? It is a, we can say that we have a different name for this layer, compute layer. You can say that query processing layer or virtual warehouse, right? So query executed in this layer, right? So whenever you fire the query, right, the query will first come to the cloud service layer, then it will go to the compute layer for the processing, right? There they are using the MPP, right? um, Parallel processing, right? Massive parallel processing, right? So multiple threads are running to bring the data for you, right? That's why. And the warehouse has a temporary memory and the cache. So this is a temporary, right? So whenever the warehouse is running for a, suppose it is running for a five minute, so the data will be available there, right? Okay, and each warehouse is independent and with no impact on the other warehouse. So suppose we have a three, if you see in the diagram, we have a three different warehouse. So one warehouse will not impact the other warehouse. So they will do their work, they will do, it will do its own work. Suppose one warehouse is used for loading the data, one warehouse is for queuing the data, one warehouse for the dashboard, to run the dashboard and all that, right? So like that way, right? Each query results remain in cache and purge after some time, right? So there are different concept of cache is there, right? So I told you that result cache, right? So in the result cache, the data will be there till 24 hours if we run the query for the first time, right? Okay. So here is the what I am talking about that, right? So this is my cloud service layer. Here compute. This is my cloud. This is my cloud, right? S3 bucket, right? Storage is there, right? So I told you this. See, if the user is firing the query, right? So what it will do, it will load the data. If you see the color, right? All are dark blue, then light blue, then green and gray. So that what I'm trying to show that, right? It is storing in the columnar format. Okay. For each table data, this is a one table data, but is storing in the columnar format. So what will happen when the user firing the query, right? So here, so first the user will fire the query, right? So first what it will do, it will try to connect this to the Snowflake, right? to the using either the user will connect to the web UI or ODBC connection or from the command line where he's firing, right? So first, the second step, what it will do, it will check. The second step, it will check the result cache will be there in the cloud service lab. It will check if the match the query, whatever the query you are filing, the match query is available or not. If it is available, it will check the same query is available, then it will go and check in the result cache. Then it will return the result for you. That's why from first to second, it will give you the result. If the query is run by previously, okay. If suppose we are running a fresh query, right, first time, so it will first check. It will say there is no result. Then it will go to the further step. So what it will do, it will create a explain plan, the optimizer process query, right? Then it will send this query. It will create a one plan for that, right? How, what filter condition and where to where from where and all the metadata information it will get, and it will build the query, and then it will send this query to the fourth step, to the warehouse processing there. So I told you that warehouse is nothing but our compute, right? That their work is to do a compute, right? So it will scan the all the needed local SSD will be there, right? Cache will be there. And what it will do, it will send the query to the storage. And then what it will do, it will get the result from the storage, then bring the result to the virtual warehouse in the local SSD. It will be cache, it will be shared because my warehouse is running. It will be, then it will bring the data and show the user to the result cache, and then the result will be shown to the user. Okay, if the same query run by the same query is run by the user, right? So what will happen? It will get the data from the result cache. Now my after 5 minutes, I have set my virtual warehouse in such a way that, because if my warehouse is running for a long time, so what will happen? I need to pay for that, right? So we have said that, right, it will be suspended if no query is running. It will be automatically suspended, whatever the time duration you have fixed, minimum. So I fixed that for after 5 minutes. If my warehouse is idle means there is no queries running. So automatically it will be stopped. Okay. So whenever you run the query, again it will be resumed. Then again for the like that way it is. So these are the different caches are there. What are the caches and all that? These are the things are there, right? So Sai, you want to take? So any question till now? Hello? Hello?
Yes, Vicky. Can we take questions at last? Can you please
Yeah.
go to DBT now?
Yeah, DBT here. Just a minute.
Vicky, are you planning to teach the Snowpark also?
No, Snowpark I have not planned actually. First we need to complete this thing, Snowflake. And in the Snowflake, all the features are there, right? Somebody asked this thing, right? Course content, right? Just a minute.
Sayed, this course is limited to Snowflake data warehousing, DBT, core and cloud, as well as Azure Data Factory. Snowpark is a little bit vast. We'll complete that one in the upcoming trainings.
Okay, so these are the things we are going to cover. Who is asking that, right? So we will cover the what is cloud.
Vicky, please share your screen again.
It's not coming.
No.
Just a minute. You're able to see, right? You're able to see, right? Right? Hello? Hello?
Yeah, yeah, yes.
Yeah. So these are the course content, and
Yes.
we will understand what is the because in the interview they will ask you, this is a warehouse, right? So what is warehouse? In the warehouse, what are the concepts? What are the concepts of the warehouse? They will ask you what is fact, what is dimension, what is SCD. So these are the things we are going to cover, right? So here we are talking about what are different edition, how to do a calculation, right? and SnowSQL and Python connector, how to connect the Snowflake through the Python, right? Without opening anything, our code will run from the Python. Okay. And here the internals of this thing. And here we'll see what is bulk load, right? In the bulk load, what are different type of tables, external table, internal tables, file format, copy command, unloading. See, we are loading the data. Now we want, it just suppose it, I have a data in the table. I want to get that in the flat file, how to do that. Okay. And here we will see the data governance, right? How to create the different roles. What is RBAC, right? They will ask you rollback access control, right? So how to create the user, how we are giving the privilege and all that, right? Then we are seeing here data sharing, time travel, cloning, everything practical, no theory. Okay. So everything we will cover the theory also, we will do the practical also. I will show you how we do that, right? And here we look into that, right? How to maintain the SOS and all that, right? Here we will see that what is
Can you
Snow.
explain the what about the security level?
Sorry.
Yes, side. Yeah. Snowflake security.
So in the security level, right, we will see that how we do the data masking, row level security, column level security, how to use the tagging and all that, right? Some suppose I'm using a account. Suppose I'm creating working for a banking client, right? So in there, right, so there are PII elements are there, right? So personal information or patient information, I don't want to display with that, right? How to do the data masking and all that, right? How to tag that, right? It should be tagged that, right? These are the columns are high tagged, right? It should not be visible to other user and all that. Okay. And here we will see Snowpipe materialized view, how to automate, how to do a SCD type implementation from the stream and task, right? And here we'll see UDF, right? Using the SQL, right? How to create the stored procedure, because something we want to do a automate, right? So I'm writing a copy command, right? But I want to automate, right? It should be done dynamically. So we can create a stored procedure, we can do it. And some different use cases are there, right? I will show you one use case. Where is that? What? See, what is that? See, everything, scripts and everything will be there, right? So how to do a data replication and all that, right? So we created two accounts, right? And do a disaster recovery, right? So one account is my Azure, right? And other account is my AWS. So this is my primary, this is my secondary. How to do that, right? Data replication. So these are the things we are going to cover, right? In the real time, what is happening, right? So these are the things. So now I have to show the DVD, right? Just a minute.
A question around this, like before we proceed with DBT, can you please guide
Yes.
like how is the Snowflake integrated with DBT? Like what is the reason that we need to learn DBT along with Snowflake or ADF along with Snowflake?
Just a minute. I will tell you.
Sure.
Yeah, sharing my screen, Vicky.
Yeah, I'm sharing. I'm sharing.
Okay.
You're able to see my screen, right? Yeah. So somebody asked me why DBT, right? so what happened, right? The DBT is basically is a data build tool. It is doing a T of ELT. When we're doing ELT, right? Extract, load, and transform, right? So the transformation part is done by the DBT. So there are certain things, right? We are not able to do in Snowflake, right? Like documentation, right? We want to document lineage. We want to build a DAG, right? You want to know that from which data the data is coming to this, right? I will show you the DAG, right? So then you will give the clarity, right? What I'm talking about. And the like unit testing, right? In that Snowflake, we don't have a constant, right? Only Norton constant is there, right? But I want to maintain the primary key, foreign key relationship, right, within two tables, right? So if there is no match, suppose I have a department table and employee table, right? So whatever the departments are defined in my master table, 10, 20, 30, HR, payroll, and the one more department is the sales department, marketing department, HR department. In employee table, only the employee that belong to that department should be there. It should not be the department 40 will be there, right? Because the relationship is not there. So that kind of relationship we want to maintain, right? So the DBT will give a help for us. I'm able to answer your question.
Yes, you are. Thank you. And is it the same purpose for which we need to use?
Your voice is breaking. I'm not able to hear you.
I'm audible now.
It's,
Hello.
yeah, please. You're saying something?
Audible?
Hello?
Yeah. So, yeah. That is it the same purpose that we need to use ADF as well? Like there are certain features in ADF or in Snowflake that are not. There are certain features that are not available in Snowflake, and that is the reason that we need to use ADF for DBT. Right?
No, actually, in now the what we have studied in the market, right? If you're going as a Snowflake developer, right? So every company are now looking for Matillion, one ETL tool, either ADF or Matillion, and one DBT is required. DBT is not a ETL tool; it's a data transformation tool. So what are the test cases you want to write? Everything you can done it, right?
But we can do the transformation
Okay.
with ADF also. Why we are moving to DBT?
Sorry.
We can done the transformation. We can do the transformation through ADF also.
No, from ADF you are doing the source data, right? In DBT, what happened, right? You are not bringing the data outside your data warehouse. You are building, see, if you see this diagram, right? The data, the DBT is built on the top of warehouse. If you see this, right? If you see here, right? Azure, this is a Snowflake is there, right? Any warehouse, right? Either it will be in the Redshift or BigQuery or Spark, right? Or Databricks. So this tool is built on the top of warehouse. So we are not bringing the data and doing that on the fly. We are converting here only and loading the data. So once that, see, if you see the first diagram, this source data is there. We are using the loader, right? So either you can use any of the ETL tool. So using this thing, right? ADF, you are loading the data, bringing the data to the Snowflake, your warehouse. Now the raw data is there. You are sending to DBT, and the DBT will transform the data as per the requirement. Now to write a slowly changing dimension, you need to write a code, right? Logic, right? Hello. To maintain
Hello?
the SCD, so I want to maintain the SCD type 2, right? So what you have to do, right? You need to you load the data first, right? Then you maintain the start date, end date, right? Then you have to write the merge statement, right? It should update. It should so once the data, old data come, right? You want to maintain the history, right? Suppose the customer is there, he is staying in India in 2021, right? Now he moved to US in 2024, right? So we want to maintain the history, right? When he's staying in India, till what time is maintained, till what time is there, and from where, from US, what time he started, right? So to write that, you required it, right? To write a code, right? Hello? Hello?
Yes, Vicky, continue.
Yeah. So code is required, right? But in DBT, right, just you need to configure, right? Everything done by the DBT itself in the backend. Okay.
So are we going to work on a project that covers both usage of both
Yes.
ADF and DBT
Yes.
along with Snowflake?
Yes.
Okay. All
We
right,
are
that
going to
helps.
cover.
Thank you.
Yeah.
Yeah, thank you, sir. Next.
Yeah. And so what are the things, right? So we can do a deployment, right? Versioning we can maintain, right? In Snowflake, currently we can't maintain the versioning, right? So now then they come up with a new feature of the Git, right? But it's in the public, it's in a preview phase, right? But in DVT, you can maintain the versioning, right? Suppose you return some code, right? And the user want to upgrade something, right? But after the second sprint, he's saying, no, I want to go for the first sprint. So what code you written, you have a maintaining the versioning, right? Deployment is there, right? Very easy deployment. Just connect that, right? And deploy where you want to do the deployment and all that. Okay. So this is basically built on the, so that at a high level we have shown that, right? From the data, from the loader, right? Any loader, right? ETL tool, we are loading the raw data into a warehouse. So these are the warehouse are there, right? The Postgres and warehouse is there. On the top of that, we are building the DBT. So DBT will take the raw data, transform and load the data into warehouse itself. From that, the BI team can go and take that. So this is the high level, you can think that. So this is the warehouse. So from the Snowflake, the data will come, how the data will load it. Then the DBT is built on the top of that. Hope did the answer, right? Hello?
With ADF also we can load first after do the transformation.
Sorry?
With ADF, we can do the transformation after loading.
After loading, we can do the transformation. So again, you bring the data to ADF, right? Hello?
Hello.
Yeah, ADF, we are bringing the data, right? Here in the DBT, we are not bringing the data.
Need to bring a data, we need a space also in ADF.
Sorry?
It take a storage. ADF take a storage for bring a data and do the transformation.
Yeah, but we don't want, right? But what we are doing here, we are doing the transformation, we are using the DBT.
But we can do the transformation through ADF also.
We can do it. But for that, you need to bring the data, right? ADF is basically we are using to load the data from the different sources, right? Like you are bringing the JSON data, right? You want to do a flattening and load the data into that. Now the business logic you want to apply, right? Again, you bring the data to ADF, huh? That's the problem. That's why.
Okay, continues.
Yeah. So that's it from my side. Sai, you can take it.
Okay, continue.
Sai?
Continue, sir.
No, I'm continuing, right? Sai is there, right? No, she's explaining about the ADF and all that, right?
Yes, sir, Vicky. Thank you. I'll share my screen. I think my screen is visible, right, Vicky?
Yes.
This is loading. Yep.
Yes, yes. Sorry for the wait. Yeah, in this Snowflake data engineering training, as you all know, we are covering Snowflake, DBT, and ADF. Okay, this is the curriculum which I'll be sharing with you. And Vicky is the trainer for Snowflake and DBT, and the trainer for the Azure Data Factory. I'm a Azure Data Engineer as well as a Snowflake as well. And I have experience in Amazon Redshift, Amazon S3, Informatica Cloud as well. I'm a cloud agnostic data engineer. Okay. From here, ADF things will come. Okay, why we introduced ADF in SQL data engineering means because we don't want to miss few opportunities which they're asking for Azure Azure Data Factory with Snowflake. Okay, that's why we have integrated Azure Data Factory, and few job opportunities are there for AWS Glue or Airflow as well. So Snowflake is the data warehousing tool which expecting the mixing of a few technologies. That's why we are trying to get few roles like a Snowflake developer, Snowflake data engineer, and Snowflake with DBT and Snowflake with ADF. And here in the ADF course, we are covering from basic to advanced level. Advanced level in the sense we are covering the dynamic parameterization as well. And here we are covering introduction to Azure Data Factory, where we are providing an overview and key features and benefits of Azure Data Factory over other ETL tools. And we'll explain what are the use cases for Azure Data Factory and the scenarios where we are using Azure Data Factory as well. And here we'll do some lab like setting up Azure Data Factory environment in Azure portal. And we'll explain what are the different kinds of integration runtimes and what is the definition and the purpose of integration runtime in Azure Data Factory. And we'll see what are the different types of integration runtime like Azure self-hosted and Azure SSIS integration runtime. And when and how to use each integration runtime. And we'll do some lab as well. We'll do some lab setting of Azure IR, self-hosted IR. And linked services is a connection, means if you wanted to load data from SQL server to data lake, at the time data lake and SQL server will be the linked services we have to create in Azure Data Factory. And we'll show you how to create and how to manage the linked services as well. We'll do with an example, and I'll explain each and every we'll pass the steps, best practices as well. And in the linked services, it is the good thing for securing our linked service, right? It is not good case to expose passwords and the correction string to ADF or any other tool. So here we are introducing Key Vault as well, Azure Key Vault. So here I'm going to explain Azure Key Vault as well for securing your password or connection string. We'll do creating and managing the linked services with a Key Vault as well. Azure Key Vault is a secret managing agent. Okay, that is a one resource in the Azure portal. We'll look into the data sets, and here we'll create the data set and we'll configure the data sets. We'll do the best practices of data sets, and we'll create so many data sets, and also we'll go with the parameterized one as well. And copy activity. Okay, this is the one of the important activity where this copy activity make some uniqueness to the Azure Data Factory only. It is very easy to load data from one source to the destination, and I'll show you how to do the step-by-step things to load data from source to the destination, and the common scenarios and how to troubleshoot the things whenever the failures happen. Okay, here we'll see in the copy activity each and every feature as well. In copy activity, we have features like hierarchy and
We give the ETL process in ADF.
hello. Can I take the questions at last?
Okay.
Okay, thank you. Thanks for understanding. And here we'll do some labs like copying data from different data stores, like source and destination. And here in the copy activity, I already told you there are few features: merge files, hierarchical files. We'll do those things as well. I'm sorry for that. And we'll go through the Azure Data Factory activity. This copy activity and the data flow activity are the two important activities in the Azure Data Factory, where we'll do use it for to move or transform data and to load the data. Sorry for, give me a minute.
So I think you all are working professional, right? Or searching for a job or what exactly? I just want to know that. Or switching from other domain to the Snowflake.
Yes, Vicky, I think there are a lot of working professionals, and we'll go then.
Okay.
We'll take the questions, and if you wanted to change your career, also we'll give the day, the good guidance as well. Okay, and we'll start the session. And here the data flow activity, right? And data flow activity is also used to transform the data and to load the data. And ADF, it called for a code-free orchestration, right? And by using data flow only, we can achieve the code-free orchestration, where we can do transformation just doing drag and drop. Okay, if you wanted to do like sorting or filtering, at that time we have to use this data flow activity. That is very easy. Just we have to do drag and drop the transformations. That's it in the data flow activity. I'll try to explain all the transformations in the data flow activity as well. We'll implement the things in hands-on lab as well. Yeah, in every activity or every use case, I'm going to prepare one. I'll show you one pipeline, and you have to do your lab as well. And at the end of the session, you'll have some labs to complete the things. And coming to Azure integration runtime, we here Azure Data Factory, while creating, it is going to give the auto resolve integration runtime. But if you wanted to create our own Azure IR, we can create. I'll show you how to set up the Azure integration runtime and what are the configurations options and best practices to create the Azure IR as well. And the common issues and resolutions also we'll see in while doing this lab. We have one more lab here. And coming to SSIS integration runtime, here for this also, I'll give some overview on SSIS steps to configure and manage self-hosted integration runtime. And here we'll do some migration tips as well, because the self-hosted integration runtime is used to establish the environment. It is like an infrastructure between the on-premises and the cloud things. Okay, the ADF. And by using this, we can suppose if you wanted to load data from SQL Server or Oracle on the on-premises to data lake or data warehouse, we have to use this SSIS or not SSIS, self-hosted integration runtime. This this SSIS integration runtime is used to shift and lift the existing SSIS, because SSIS also is an ETL tool that is also a Microsoft product. Okay, because Microsoft don't want to lose their existing customer, so that's why they have designed this integration runtime. Just they wanted to lift that pipelines existing in the SSIS and shift into the integration runtime. And self-hosted integration runtime will do in the lab. And system assigned managed entity, user assigned managed entity. These two are the security things. Okay, while creating the linked service, we have the options to secure our passwords, usernames, and all. And system assigned managed entity and user assigned managed entity are also one of the authentication types. Okay, and we look into service principal, system assigned, user assigned identity, and account keys as well. And we'll implement those linked services with the use cases. And we have to do some labs as well here. And we'll go through the lookup activity and metadata activity. These are the control flows where these are used to fetch the metadata information or the output of the table. Okay. For this, we'll see how to configure the activities, and we'll look into the use cases in the real-time examples. Because those two activities are the important ones to do the things in looping. For each activity, understanding for each activity, like it is just like in for each for loop in the programming, and how to configure that one. What are the use cases for each activity? Failover and validate. Failover and validate activities. Okay, these two are to do the error handling mechanisms. We'll go through this failover and validate activity as well. And conditional activities, if activities, which activity, and until activity. We'll look into all these activities and how to do the conditional things by using these activities. Set variable and append variables. Okay, these are the two activities where whenever we are dealing with the parameter variables, at the time we'll use this set variable and append variable as well. And stored procedure activity, we'll look into the stored procedure activity as well. And how to configure the stored procedure activity. We'll connect with the data warehouse and the database. We'll execute the stored procedure activity as well. Different kinds of triggers, because triggers are very important to schedule the jobs. And here we have 3 triggers: schedule trigger, tumbling window trigger, and event based trigger. We'll implement all these triggers, and we'll look into how to manage that one and how to monitor the things. And at last, we'll look into the monitoring things and managing the pipelines as well, how to debug, troubleshoot the things. And because we are doing some real-time projects here, there we are going through all these things as well. And advanced topics also we are covering here: incremental data loading, handling schema changes, integration with other services like Azure Synapse Analytics, Databricks, SQL Data Warehouse, and SQL Database. All these things we'll try to connect. And these are the real world case studies which we are covering here. These are 3 real world case studies which we are covering here. First, we'll load data from on-premises. We'll take SQL Server as an source. We'll load data from SQL Server to Data Lake, and Data Lake to Data Warehouse, maybe Azure SQL Data Warehouse or Snowflake. And building a data warehouse with Azure Data Factory, and integrating ADF with other services also we'll see. And here we'll implement the SCD type 1. And also we'll do the data migration as well. And for this batch, we are implementing banking related projects. We'll have in this whole curriculum, in this whole course, we are explaining you the best practices, security best practices as well, and we'll show to how to optimize the performance and troubleshooting the common issues. And we'll cover, we'll provide you the labs. We'll provide you the blogs, art related blogs, related articles, and we have the regular question and answer sessions, like doubt clearance sessions. If you want, we can address that one as well, and dedicated time for troubleshooting your issues and discussion. If you want, we can have some more discussions as well, and the guest lectures also we are planning to have. And certification preparation will show you what are the relevant certifications in Azure and Snowflake. And study tips and resources also we are going to provide, and practice exams, interview questions, mock interviews also we are providing here. And this is an advanced course, not only Azure Data Factory, Snowflake, and DBT as well. And here, in coming to the ADF, we are creating the real-time projects in the dynamic parameterization. Everything will dive from the table, not like in creating multiple activities for loading 50 tables, load data from one source to the destination. So almost we'll load data for multiple tables, not to the single table or single file. That is the projects which we are going to work here. Yeah. And, if you are going to complete the task and labs whenever the class completed, then you are in the good position where you'll get some really real-time experience. If you won't practice right, you won't get the real-time experience. And why we have to choose our institution means because we have the best curriculum, If you see other institutions curriculum as well, they don't have this much of detailed concepts and related data as well. Every time they are just comparing the things. I'm not pointing to anyone, and they are explaining the same projects in each batch, and we are changing the projects and as well as data, and we are providing the labs, assessments, and so many things we are planning. And also the course is very affordable. The course fees is 20K. The course fees will be 20K and the duration will be 50 days. And the time will be daily. We'll have the classes in the evening times, 8 to 9, or we are flexible for half an hour before, half an hour after. No, it depends upon the student's wish. But mostly it will be on the weekend evenings only. In weekends also we have the class for ADF as well. And the course fees will be 20K for whoever joined this demo. After the batch started, batch is going to start at in this Monday, coming Monday, 19th August 2024, the batch is going to start. Okay, that is the information about this course. The course is going to get 20K. Whoever joined for this demo, not only this demo, we are conducting one more demo. Whoever joined for these 2 demos, we are offering 20K. If whoever joins after the batch starters, we are giving the course for 21,000. Okay, this is the curriculum, and we have the guest lectures, and you will get the access for the community where we are giving the free webinars continuously. We'll get the guest lectures, and we'll conduct the master classes as well. Sometimes we'll have the contest on SQL or Python, PySpark. Okay, you are happy to join wherever any of these things. Those are free only. And this is the course details, and we are providing the placements assistance. No job guarantee, but we are there to take the mock interviews, providing the interview question and answers. Yes, this is about the Snowflake Data Engineering training by Vectoretech. Any questions? Happy to take the things. Anyone has any question? Please raise now your question. If anyone interested, right, please ping in the message group, or you can ping me. I'm the admin to that group wherever you are there. Or ping to Sushri. She is also the admin. Yeah, I think everyone is clear, right? Vicky, anything to wrap up?
So if they have not joined the community and WhatsApp group, please join for more updates.
Already told you the training will be 50 days. Okay, 50 plus days, maybe 1 or 2 days. Okay, how much of experience I can put in resume according to your course. Okay, if you are going to do the things, whatever the labs we are providing, and what are the assessments we have given, then you can keep almost 3 to 4 years of experience. Because if you see the curriculum, almost if someone is working on the same tool 5 years, 10 years also, they don't have that much of knowledge. That type of curriculum we have designed, but it depends upon you. You have to practice the things, and you have to daily the practice should be done. It is not the case the practice should done in the weekends or after 10 days, after 20 days. If you do the practice every day, and you can happily keep 4 to 5 years of experience. Yes, and any questions? You can chat, you can type your question, or you can speak up.